in the winter with some air movement to promote the drying. They will freeze, and in most cases, if they're frozen, they're going to be have to be scrapped. And one of the biggest things is they're very sensitive to formula changes. Changing one item, a dispersant or a surfactant, can totally change the performance of your product, including the package stability. Tips, what I've found in the past that oven stability does not always reflect real-life conditions for viscosity stability. I had one product that I worked on for about 6 months. I never got past a 45-day oven stability. But that same product could sit for 2 years under normal storage conditions and still be usable. Your rheology modifiers are important. You need to have enough of these in these systems to provide the sag and sealing resistance you need in a finished project. You may also need to blend your coalescents to obtain the best properties as far as dry speed and finish durability. Viscosity stability can be affected by the total solids of the product. It can be affected by your rheology modifiers and your coalescents. Another big thing to be concerned about is your dispersant and surfactants, because the levels of these things can really affect your performance as far as durability and corrosion resistance. The biggest drawback I've always found with these compared to alkyds is each resin sort of behaves like itself. In an alkyd, you can pretty much get a set of additives that you like to use, and they'll spread across quite a few different systems. But in water systems, that's usually not the case. Every resin system is going to need its own set of dispersants and additives to give you the best performance. Water reducible alkyds. These have also been around for quite a while, probably at least 25 years. Basically, these are alkyds that have very high acid numbers, and when they're neutralized, they become water soluble. Your common neutralizing agents are usually ammonia because it's the most volatile. In baked systems or forced dry systems, you can use maybe DMEA or a little bit slower amine like triethylamine. The best thing about ammonia is it's not considered a VOC, where the rest of them are. VOC levels, really about 2.8 pounds in a gloss. It's about the lowest you're going to get because you are limited by the water co-solvent ratio. You need roughly an 80-20 ratio for the best stability in these products as far as holding together in the can. They offer some advantages. They apply at the same solids and use the same equipment as a conventional solvent-borne system. They're fairly low cost, properly formulated. They're non-flammable. They can offer very good dry, reasonable performance, and they can deal with metal that's not exactly the world's cleanest. Drawbacks are they're low solids. It's really hard to get dry films over 1.5 mil. If you want any higher than that, you're going to have to two-coat the system. And probably the biggest drawback, especially if you're trying to use these on a on-shelf situation, is they will hydrolyze over time. That just means they'll lose their drying characteristics. Usually if it's an industrial situation and they're made for a customer, on pretty much something you're going to use the next 3 to 6 months, you're not going to have a problem with these. Tips to sort of keep your things from hydrolyzing as much. Keep your heat, your process heat at a minimum, especially after the product's neutralized. You can, my favorite dryer combination has been usually a combination of product like a Drymax and Cobalt. You can modify these things with acrylic emulsions. By doing so, you will raise the solids. You get better dry. They actually will spray better. You get a little bit of more sag resistance out of them. You have to watch the level because you can lower the gloss of the final product. And properly formulated, you can get a pretty stable product. Most of my work I've done two ways. I've done either like about a 10% acrylic modification, or I have seen ones that are the other way, where it's much more of an acrylic emulsion modified with some water alkyd in a primer application. Don't be afraid to blend resins. A lot of these water alkyds, the fast dry ones, will encapsulate and not dry through as thoroughly or as quickly as they should. Adding a little bit of a slower resin will help that process. Another thing you can do with these resins in an unneutralized fashion, if you just use them as a solvent-borne system, which I've done, is they have a very high acid number, and the acid number tends to help your adhesion to hard to adhere to substrates like aluminum. It'll actually almost give you an etching process. So I say these have been around a long time, and if you're interested in these things, Reichhold, many, many years ago, put out a wonderful brochure on how to work with these systems. And I'd encourage you to look at that if you want to use these type products. High solids. Basically, this was one of the first attempts to meet VOC regulations. They're basically oil alkyds with, your phthalic, pentaerythritol, standard alkyds, but they're cooked to a lower molecular weight, which gives you a lower initial viscosity and solution viscosity. VOCs 2.8 to 3.5 are well within reach. Low cost, there is one advantage to them. You can get pretty decent performance out of these things depending on the oil length of the top coat. The drawbacks, because they are lower molecular weight, the dry times tend to suffer, and because of the higher solids, especially if you're painting complicated pieces, you will get very, very high film builds. In the past, I have formulated some of these systems down to 250 grams per liter in a primer using a blend of exempt solvents. Another drawback of these things, people may need new application equipment. Usually they're going to need an airless or an air-assisted system along with heaters, especially in the winter up north. If you don't keep the paint at 70, 80 degrees, it gets so thick you really can't atomize it. And they are flammable, so that's another thing that has to be considered. Some of the tricks you can use to lower the VOCs of these things, depending how close you are, is to change out, first thing to do is change out your heavier solvents. Say toluene with MEK. You can find the most efficient solvents. Just run a spread of solvents and see which one reduces your product the quickest. You can use hydrocarbon resin modification to a small degree, or you can use reactive diluents. Or in primers, you can even use a small amount of raw linseed oil, which is very thin at 100% solids. Last but not least, you can use the exempt solvents that were mentioned before. I have found from past experience that usually in the case of acetone, which is the most commonly accepted one, maybe 10% is about as far as you can go before you start losing your application properties. It'll just dry too fast. If you need to go further than that, you're probably going to need a blend of the exempts to get down to the level you want. And if you really want to force the issue a little bit, especially for interior products, you can add a pound to a pound and a half of a very fine particle size filler, such as an omnicarb UF, to the products. And that will give you enough extra solids that you can drive your VOCs down lower and still maintain a decent application viscosity. It's not a good idea for exterior products, however, because it will tend to degrade your exterior performance. Conclusion, development is really customer driven. You have to give them what they want if you're going to make the sale. At the present time, while you're developing a product, if you can go somewhat lower in VOC, I would say go for it if it's not going to affect your application or your costs. Thirdly, don't oversell a product. I mean, everybody likes to sell a very high-priced product, but a lot of people really don't need that, and they don't want it. The best thing to do is keep it as simple as possible. And lastly, make sure you know where the regulations are going in the area that you're going to be developing this product for. If they're going to change in 6 months to a year, you might as well take that into account now. Because if you don't, you'll be facing them again in the future. Great. Thanks. Thank you for your time, and here's Nick.
Okay, so now we're going to open it up to questions, which one of the questions that I received very early on was whether or not we're going to have the presentation available at a later date, which we are planning on having a recorded file up and available later this week. Once we get the file all appropriately situated, we'll let everybody know that was on today, or if you had registered, that we will have that available. Like I said, if you have any questions, please type them into the little prompt on your GoToMeeting control panel if there is any other questions for today. In the meantime, if you do have any further questions that something's just kind of not right of mind, we do have the contact information here for both Scott Moore and Dennis Buell. Dennis is our business development manager. As I mentioned earlier, Scott is a coding specialist. So those two would be the appropriate contacts to reach out to. You can also just dial in to 800-659-7659 or visit our website, www.chemir.com, and hopefully we can help you out there on the website as well. I don't see anything else coming in, so I'm going to thank you once again for joining us today for this webinar, and if you have any further questions, feel free to contact us. Thank you.